Alright, I'm going to go through and make a video key for this week 2 assignment, which is the review for exam 6. So, I'll just start. Question 1 says, what's the mole ratio of NH3 to O2? That's ammonia to oxygen. And so you just look at the chemicals in the reaction, you find them, and you look at their stoichiometric coefficients. So the ratio should be 4 to 5, which can also be written as 4 moles NH3 to 5 moles O2. Okay. Part B. How many moles of oxygen would need to react with 8.5 moles of NH3? So you start with what's given, 8.5 moles of NH3, and it's asking you to figure out how many moles of oxygen. Okay, so you're going to convert to moles of O2, and you need to convert from moles of NH3. So you notice how I put moles of NH3 on the bottom to cancel with the moles of NH3 that was given. So then I fill in the mole ratio. Again, it's a 4 to 5 mole ratio. So I'm going to end up multiplying 8.5 times 5/4. The ammonia moles cancel. And let me pull up my calculator. I would make sure you have a calculator. I know you could do stuff online when you're taking the exam, but I would just have one ready. So 8.5 times 5/4, 10.625, but I'm going to round it to 2 sig figs, right? So that would be 10.6 moles of O2. How many moles of NO3 or of NO would be produced if 0.5 moles of NH3 reacts with an excess of oxygen? So here's what starts with 0.5 moles. Oops, I'm sorry, my pen just lost connection. It's been doing that, so give me a second. I don't know why I'm having so much issue with it today. Move my phone out of the way. Maybe that's it. Give it a sec. Reconnect. There we go. Okay, so 0.5 moles of NH3, and it says how many moles of NO would be produced. So I need to get moles of NO. Okay, and I need to convert from moles of NH3. So I need to go look at that ratio. So I know 4 moles of NH3 was the stoichiometric coefficient, and there's 4 moles of NO. So hey, that turns out 4 over 4 is just 1 to 1. So when you multiply 1/2 times 1, you just get 1/2. So we end up with 0.5, but now I'm in moles of NO. Okay, moving on to number 2. It says copper plus silver nitrate makes silver plus copper nitrate. It's already balanced for us, so I can just say solid copper reacts with aqueous silver nitrate, and I don't need any Roman numerals because silver just has one oxidation state, so it's always a +1. Makes so silver makes solid silver, and I think we forgot. My pen keeps dying. I don't know what's going on. This could be painful, so you can skip around in the video. Don't wait for me. If it keeps doing this, I might just kill the video and do this in non-video mode. I don't know what's going on. Okay, give it a second to reconnect. Oh, there we go. Undo that. Solid. Oh, see, it worked for just a second. Can I write with my finger? Nope, I can't write with my finger. Okay, here it goes. Maybe I'm just writing too fast. Solid copper reacts with aqueous silver nitrate and makes solid silver, and copper, this one we will need a Roman numeral, copper 2 nitrate. And I could put the word aqueous in. Okay, or I could say copper 2 nitrate solution. And the way I know it's copper 2, I look at the charge. Nitrate is usually a negative charge, and since there was 2 of them, I need this to be copper 2 plus. So that's copper 2 nitrate. Okay. Part B, in a balanced chemical equation, what needs to be equal on both sides of the arrow? The amount of atoms of each type of element, or each element, sorry. You could also say the number of moles of each element. Yep, I think it's when I go too fast. Like, can't keep up. I don't know. Okay. Number 3. CH4, which is methane, plus 2 oxygen molecules make carbon dioxide, and 2 water molecules. How many moles of methane are needed to make 88 grams of carbon dioxide? So I start with 88 grams of CO. Oh, while my pen is reconnecting, I'll just show you how I would do this. See, I was troubleshooting my pen earlier. Let's see if I can come in here and I can just type in carbon dioxide molar mass. And there it is, 44 grams per mole. So grams. Pen is still funky. Let me try. My goodness, guys. Okay, let's see if I get a pen. There we go. Okay, there's 44.01 grams of CO2 in one. Nope, I've lost it again. 1 mole of CO2. And then it's asking how many moles of methane do I need. So I need to convert from 1 mole of CO2. Oops, and actually I don't know if it's 1 yet. To moles CH4. And I go look at my stoichiometric ratio. So there's CO2 and methane, and it turns out the coefficients are both 1. So when my pen comes back, I wonder if there's something. If I write like this, maybe it's at a weird angle. And I've checked my batteries, I've done everything. Nope, hitting it doesn't work. Okay, I'm hopeful it works. Alright, so it's 1 to 1. So really, all I have to do, right, cancel units, moles of CO2, grams of CO2. I know my answer is going to be in moles of CH4 because that's the only unit left. And really, it's just 88 divided by 44, which I could do in my head. 2, and I need 3 sig figs. So that is going to come out to 2.00 moles of CH4. Alright, moving down. How many grams of oxygen are consumed by 6 grams of methane? So 6.00 grams of CH4. Here I need to convert from grams of CH4 to moles CH4. Okay, 1 mole of CH4. Carbon, I can do this one in my head. Carbon is 12.01 and hydrogen is 1.01. So let's see, 12 plus 4 is 16. It's roughly 16.05 grams. And then I need to get to grams of oxygen. So first of all, I'm going to convert from moles CH4 to moles O2. And I go look at my ratio. CH4 to O2. There's 2 O2s for every 1 CH4. Okay, and then after I've got that ratio, I can go from moles O2 to grams O2. Oxygen has a molar mass of 16, and there's 2 of them, so I think this is 32.0 grams per 1 mole. So I'm going to go through and calculate. I'll use my calculator this time. So typing it in, I would type in 6 divided by 16.05 times 2 times 32. And I get 23.925, which rounds to 3 sig figs, 23.9. And I look, my last unit that didn't cancel is grams O2. Okay, how many grams of methane would be needed to make 78.0 grams of water? So let me just show you how I would set this up quickly, and then I'll fill in the numbers. I need to go from grams H2O to mole H2O. Then I need to go from mole H2O to the moles that they're asking me for, which is methane. And then since it's asking me for grams of methane, I need to convert moles methane to grams methane, which now I can go back in and fill in all my units. There are, would we say, 16.05 grams in 1 mole. CH4 to H2O, I go look at my coefficient. CH4 to H2O, there's 2 H2Os for 1 of those. I know 1 mole of water weighs 18.0 grams. And then I can do my calculation. 78 divided by 18 divided by 2 times 16.05, 34.775 rounded to 3 sig figs would be 34.8, and this would be grams CH4. My pen's doing good. Okay, how many grams of water are produced from 99 grams of hydrogen? And we're going to assume excess oxygen. So if it doesn't tell you, then just assume that you have excess of the other reactant. So I have 99.0 grams of hydrogen. And when it says just hydrogen, it usually means hydrogen like the reactant gas. We don't call hydrogen H2, we just say hydrogen, but we really mean H2. So 99 grams of hydrogen, and it says how many grams of water are produced. So I need to go from grams of hydrogen first to moles hydrogen, then moles hydrogen to moles water, and then from moles water to grams water, which we know that was 18.0 grams in 1 mole. The ratio of hydrogen to water is 2 to 2, which I could write as 1 to 1. And then grams of hydrogen, there are, 2.02 grams in 1 mole. So 99 divided by 2.02. I don't need to do anything with the 1-to-1 ratio, so just multiply by 18. So I got 882.2, which 3 sig fig says 882 grams H2O, excuse me. Okay, how many grams of water are produced from 99 grams of oxygen? 99.0 grams of oxygen this time. I need to go grams oxygen to moles oxygen. I need to convert from moles oxygen to moles water. And then I need to convert from moles water. It's asking how many grams of water. So now I start filling things in. 18.0 grams in a mole. Mole of oxygen. I go look at the stoichiometric coefficient. Looks like this time one oxygen makes 2 waters. And there's 32.0 grams of oxygen in 1 mole. 16 plus 16. So 99 divided by 32 times 2 times 18. I got 111.4, which rounds to 111 grams of water. Okay, C. How many grams of water would be produced when 99 grams of hydrogen reacts with 99 grams of oxygen? Okay, so this one is just building off of the last one. If you have 99 grams of hydrogen and excess oxygen, you could create 882. Okay, if you start with 99 grams of oxygen this time with excess H2, lots of extra H2, you could make only 111 grams. So if you put 99 of each, instead of having excess, you had exactly 99 of both. Okay, then you have to look for what would run out first, what would produce the fewest or the least amount of water. So in this case, you just compare, since it's 99 and 99, turns out that the 111 grams of water produced with 99 grams of oxygen, okay, the oxygen would be the limiting, so let's just put this, oops. Okay, and since we've already done the calculation based on this reactant that we know would limit, we would create 111 grams of water. Okay, you couldn't get all the way to the 882 because you would run out of oxygen before you run out of hydrogen. And it's because a mole of oxygen is heavier. Okay, what is percent yield? It's a measure of how much you get, okay, which is called a yield, versus how much you expected to get. So, and we can write out the formula. But this would be like if a farmer expects that, say it's an apple farmer, expects to get 800 pounds of apples off of a tree, but for some reason maybe they had a bad growing season, they only get 400 pounds. Well, 400 pounds out of the 800 they expected, that would be 50%. So, percent yield, the formula is always the I guess it'd be how much you get. So what do we want to call that? Actual mass divided by the expected mass times 100. Okay, and it's always that. So expected always goes on the bottom, and the expected mass is usually based on stoichiometry. So what you calculate is your expected amount, and then what you get in the lab, that's your actual mass. Okay, so here you go. It says 75 grams of magnesium react with excess oxygen. 98 grams of magnesium oxide is produced. What's the percent yield? So we're going to do this and get the expected mass first. So 75.0 grams of magnesium we need to figure out how much magnesium oxide is produced. So we'll go from grams magnesium to moles magnesium. I don't know what the molar mass is, so let's see if I can get it here. Oh, there it is. It says molar mass of magnesium, 24.305 in 1 mole. Okay, I need to go from moles magnesium to moles magnesium oxide, and I look at the reactant and the product that I'm interested in, 2 to 2. This time, just for an example, I'll write it in there. Of course, right, it just reduces, oops, let's see if I can switch colors, reduces to 1 to 1 anyways. And then a mole of magnesium oxide to grams magnesium oxide. That would weigh 24.305 plus an extra 16, so I think that's 40.305 grams per 1 mole. So in this case, I'm going to take 75 divided by 24.305, ignore the ones because they just cancel, and then multiply by 40.305. So I get times 40.305. I get 124.37, which again, I think everything in here has been 3 sig figs so far, so 124 grams of MgO expected. Oops, and I guess I should be basing it off 75 grams, not the 98, but anyways, it still has 3 sig figs. So, and then to get percent yield, I produced in the lab 98 grams, but I expected to get 124 grams. So my percent yield, 98 divided by 124 times 100 is 79.0%. Okay, so I've got that. Okay, number 6. This one had a typo in it. So I think Dylan Ackley found it and contacted me, and I forwarded it to Mr. England on Monday. So he found it. Let me know. This should actually say M for just metal chloride. And it turns out the answer ends up being zinc. So here you go. It says 0.55 grams of metal reacts with HCl to form hydrogen gas. So metal plus HCl forms hydrogen gas, and oops, it should say MCl2. Okay, so you write out your equation. You have to balance it. I think I need to get 2 hydrogens. I need 2 here. That also balances out the chlorine. Okay, it says 0.0085 moles of hydrogen gas is produced, so I know how many moles I produce. Calculate the atomic mass. It could have also said molar mass of the metal. What's the identity of this metal? So you start with what's given, 0.0085 mole H2, and we need to figure out how many moles of metal that was. So I look at the ratio between H2 and metal, and it looks like a 1-to-1 ratio. So 1 mole of metal produces 1 mole of hydrogen, which again, you don't need to multiply by 1, so you end up just getting 0.0085 moles, but we're now in moles of metal. So here's the key thing. You know the mass of the metal, and you know how many moles it was. So to get molar mass, you're going to do grams divided by moles. So molar mass is always equal to grams over moles. So I just take the mass, 0.55, .0085, and it comes out to, I'm going to keep some extra sig figs here for now, 64.71 grams per mole, which if you start looking around on the periodic table, let me do that for you. you start looking through them, you find zinc, copper or zinc. Probably it's about 1.5 grams heavier than copper. It's about a little bit lighter than zinc. However, if you take this and you round it to just 2 sig figs, like the 0.55, you end up with 65 grams per mole, which is pretty darn close to zinc. Okay, so I would say that, yeah, the metal is zinc, and yeah, that typo, we shouldn't have put zinc chloride in there, but there you go. I know these questions, I went kind of fast. They all start to feel about the same. We'll probably do one more limiting and excess reactant practice problem before the test next week. We'll test it out. Let me know if you guys have any questions. Otherwise, thanks for being patient with this pen. It started to work better. I really don't know what's going on. Okay, see you guys later.